All right. So if I'm not wrong, I have checked the question already. Such a good day with another bad legal problem. Make some divisible by something called p. So I think this is a divisible weak for us, and we're given an array of positive integers, and remove the smallest subarray, possibly empty, or such that some of the remaining elements is divisible by p. It is not allowed to remove the whole array. Okay, and we have to retain the length of the smallest subarray that we need to remove -1 if possible. Right, this is my thumbnail, a legendary thumbnail. And a subarray is defined as a continuous block of the elements in array. So we are okay. Let's try to understand a dry run for the few of the examples given in here. So consider like we are going through the given arrays like 4 digits, 3, 1, 4, 2. The total values of these array sum will be 4, 3 plus 1 is 4, 4 is 8, 2 will be 10. This is the total sum. And then if we remove the okay, we have a few options. So if we remove the 3 and 1 in here, so this is a 2 subarray that will be divisible by 6. Another way, if we remove the 4 only, so which will be resulting in the 6, and then we can be divisible by 6 also. Yeah, so we have like, we can consider like two approach, 3, 1 or 4. Since we have to find the length of a smallest subarray, so that's why we remove the 4, and that is the reason why output is here. So let's go for the example 2. The same approach, 6 plus 3 is 9. 9 plus 5 is 14. 14 plus 2 will be the... Wait, what did I do wrong? 7, 9, 16. Yeah, so these will be 10 and 16 in total. Yeah. So since this is given the artifact value is p, so we have to make this number to begin the 9, which is only possible is 5 plus 2, which is the length of 2. Let's consider we only remove the other 2 numbers. No, that is not possible. Yeah, so that is the only option. Yeah, that is also explained here. Okay, in this approach, since the whole sum is divisible by 3, so we just return the 0. I think that is quite similar to a little bit with the yesterday problem. How about we calculate the total first? Let's call it total. Same as the yesterday, we're going to use a reduce and then divisible by p. When we are checking, so the number's length could be within the range of according to this would be like 200,000 if I'm not wrong. So that could cause as the integer overflow, since I don't know what is the limit of from the Leetccode to run that. So if normally it is at 64-bit or 32 bits. We only have maximum is up to 4 million. So since we are using like plus or minus, it's 2 million for positive and 2 million for the negatives. So for safety sakes, what I would do is maybe do like a parameter 1 and parameter 2, or it should be the 0 and 1. I'm gonna mod inside here instead of mob the total, so that could save the performance a lot for us. And then yeah, let's go that Yeah, since this is a total, okay, this should be the remainder then. So if the remainder is 0, we just simply return the 0, which already solved the asymmetry. Let's try to check it out. Okay, in here I just return the -1 initially. So we are supposed to solve the asymmetry only, and then there could be the error in asymmetry 1, 2. Okay, correct. So next step is how are we going to solve this? So if we are trying to calculate the numbers against and against, like let's say we are in the index 0, so we go like 0 and 1, 0, 1, 2, 0, 1, 3, the same for the index 1, index 1 alone, 1 and 2, 1 and 3. That could cause us the O of n square for the time complexity. So we don't want to do like that, since it is a lot of performance taken from our program. How we're going to do is, how about we keep our remainder of sum in the dictionary. Let's call like remainder dictionary. That will be the due integer array. So we are keeping like something like sum is to index. That is our idea approach. And then let's call the one variable sum. So since we need to calculate all the way around. And then next will be just call a reset, will be the nums.count. Okay, how about we iteration through with the index of none in the nums.enumerate. So we're gonna need index and numbers. So I'm going to update the sum by calculation of the sum and num. Oh, it should be the plus, and then mod by p. The reason why I'm mopping in here is in case like the number is getting grower, so I want to keep within the b range, so we don't have to handle the like large amount of numbers in here. So let's do the dry run later on, and then let's call like a prefix num. So our prefix num is like sum minus remainder, and then mod by p. So if we consider like we are going through the asymmetry 2, we are given an array like this 6, 3, 5, and 2. So if we are using like 6, 3, 5, and 2, our fixed number will be the 6. So since the sum is initially the 0, 0 plus 6, mod by p, which is 9, our remainder in here will be the, let's consider 9, 16, to the 16, and then if we find the modulo in here, that will be like 16 mod by 9, so will be the 7. So we have a remainder, it's a 7 here. In here, what I'm going to do is since our sum is 6 minus 7, which became a -1, that's we don't want, and mod by 9, that's still -1. So to solve this problem, what we can do is to begin the positive, just add off the p arbitraries in here. P will be the 9. So if we solve this program, we'll begin the 8, and then the previous number will keep in the 8. Okay, I think that is a very terrible idea to explain to you guys. I will try to drive it later on, and let's try to continue what I'm trying to do. Let's call like previous index. What I'm going to search is if our prefix name is in our remainder dictionary. Let's call a prefix num. What we can do is we can search like the lunch. So our length will be the index minus prefix. Previous index. Since we have a previous index, a better version in our remainder dictionary, then I'm gonna update our reset with the minimum of reset and our length. So that will be our ID approach. After that, I'm gonna update our remainder dictionary with sum. So you might have a question like why I don't use the prefix num and using the sum instead in here. So the reason why I'm using the prefix dictionary as a sum is if we're using an index, that will cause us a lot of potential issue in the near future. Okay, let me try to do the dry run after have a reset. So I'm gonna check like if the reset is same as the nums count, that means like we are not able to find any of the reset in here. We just return the -1. If not, we return the reset. Okay, then there could be the one drawback. We need to define the default value as 0 and -1 in here. Let's try to run it. And voila, and if we try to submit that will be the O of n for the time complexity and O of n for the space complexity. Let's try and check it out. Yep, it's O of n for the time complexity and O of n for the space complexity. If I have to dry run for the second experiment again, so we have like original dictionary like this. Let's call like this is our dictionary. Now we have 0 is to -1. That is the original value. And what is our sum now? So we are updating the remainder. Our sum began the 6. And what is our result? Which is a count. So which is a 4. So definitely we are putting the 4 as the original. Yeah, because if we cannot find anything like, so there is also mentioned that we can remove it is not allowed to remove the whole array. So that is the reason why I'm putting the result as the nums.count. And then I'm going to iterate it through, and then I updating the sum by addition with the nums, which is in our iteration. And then I'm checking like our sum minus remainder, which is a previous remainder that we have, and then plus p, and then mod by p. So we got 8. So we're going to check like is the 8 is already in the 9, which will be like 6 minus 7 plus 9. That will be 8. So since 8 is not here, I'm going to update like our modulo values will be the sum. Since sum is 6, I'm going to update like 6 with the index of 0. And then next will be the index 1. Alright, index 1, and then our sum is now 6. 6 plus 3 is 9. 9 is mod by 9. That's began our sum to become the 0. Let's update with the 0. And then our sum is 0, and 0 minus remainder. Okay, our remainder is 7. So 7 mod by 9. That is going to be the derivative numbers if we don't have. So since we addition of the 9, so that will be the 7 plus 9 will be the 16. 16 divided by 9 will be the 7. So we don't have any prefix 7s in here. So pretty simple. We're gonna update the 7 with our index 1. And then next step, what I'm going to do is we move to the next number. Since our sum began at 0, so we are in the fight in here. So since the sum began 0 and 5, which began the 5 for our remainder, since our sum is began the 5 this time, So it will be like 5 minus 9. Yeah, 5 minus 7. And then plus 9. So 5 minus 7 is minus 2. Minus 2 plus 9 is become the 7. Since the 7 is already inside, we have values of 1. So we have values of 1, and now I'm going to detect like since we had the 0, 1, 2, 2 minus 1, which will become the 1 in here. And then I'm going to check like comparison of 1, and our result is 4. So we're going to take the middleman, so our result became the 1 in here. Yeah, that's the first number first. And then, but still we updated the sum. So our sum is a 5. And then index. What is our index now? 0, 1, 2. Next, we go into the iteration again. What do? We have a sum with a 5, and the count of result is 1, and then with a number of 2. So 5 plus 2. So our base is 5, our num is 2. So 5 plus 2 becomes 7. So our modulo will become 7. Our sum is 7. So 7 minus 7, it's 0. And 9, modulo of 9 will become that 0. So since 0 is already in there, we have a thing called minus 1. So what do? We have an index. Index is what? 3, right? Index 3, 0, 1, 2, 3. 3 minus 1. That became 3 plus 1. So we're comparing lunch is a 4. Our result is 1 at the moment. So we got the number like 1 in here. So that is the reason why we're returning the 1. Yep, that's all for it, and see you in the next video. Bye.